So in the theory video relating to this, we talked about definite integration and how we can use this to calculate the area under curves. We talked about the process for doing this and how we calculate a definite integral. What we're going to do in this video, I'm going to set you a few questions relating to this. I want you to pause the video, have a crack at them, come back and then check your solutions with the working. So here they are. I want to calculate these four integrals. So the first one is the integral from 1 to 4 of x squared plus 4x dx. The second one is the integral from 1 to 2 of 8x squared minus 6 over x squared dx. The third one is the integral from 0 to a of the square root of x plus 1 all squared dx. And the fourth one, integral from pi over 3 to pi by 2 of 1 plus 4 sine x dx. So pause the video and have a crack, come back and check your work. So the first one, integral from 1 to 4 of x squared plus 4x dx. Now, remember the first thing you have to do is check this is in an integrable form. Now this is perfectly fine. Some of the later ones might not be. This is perfectly fine. First thing we do is we integrate it. Now remember to integrate, raise the power by 1, divide by the new power. So x squared becomes x cubed over 3 plus 4x squared over 2. And we know then that that's going to be between our limits of 1 and 4. We can simplify this part here if we want, make our calculations a little bit easier. We get x cubed over 3 plus 2x squared between 1 and 4. This is where we then use the limits. So we substitute in the upper limit and the lower limit and we find the difference between them. So we start with the upper limit, so we get 4 cubed over 3 plus 2 times 4 squared. Take away the lower limit, 1 cubed over 3 plus 2 times 1 squared. We then calculate the values and we then solve the part here. So first one, 4 to the power of 3 gives you 64 over 3 plus, well, 4 squared's 16, 2 16s are 32. Take away 1/3 plus 2 times 1 squared, which is 2. Simplify the brackets and then stick the whole shebang together. 64 over 3 plus 32, well 32, turn that into something over 3 and we get 96. Add that onto the 64 and you get 160 over 3, turn it into a single fraction. And now we've got 1/3 plus 2, well that's 2 1/3, which we then turn into 7 over 3. We then do the calculation, 160 take away 7 all over 3, we get 153 over 3, and we can simplify this down to 51 units squared. Remember, include the units squared. You don't know what they are. If you do, put that in, but you have to show it's an area, so it's square units. Second one, integral from 1 to 2 of 8x squared minus 6 over x squared dx. Now remember, this has to be in an integratable form first. This isn't, so we have to change it. Remember, this has to be in the form constant times x to the power of n. So we start with 8x squared, take away 6. Remember, x squared, we can bring it up, but the power becomes negative. So it's 6x to the negative 2 dx. And we know the limits are going to be from 1 to 2. Now it's the same set of steps. Same set of steps we would have if we integrated. Raise the power, divide by the new one. So it's going to be 8x to the power of 3 over 3. Take away 6x to the negative 1 divided by negative 1 from 1 to 2. We can simplify this a little bit here at the end, and we then get 8x cubed over 3, minus minus becomes a plus 6, well, x to the negative 1 becomes over x from 1 to 2. It's always good to put this in this form. If you've got negative powers, stick them on the bottom and simplify, because that will be a heck of a lot easier to calculate. We then do our same thing, so calculate the value at the upper, calculate the value at the lower, find the difference. So 8 times 2 cubed over 3 plus 6 over 2, take away 8 times 1 cubed over 3 plus 6 over 1. Simplify these and then we get our final answer. So 2 cubed is 8, 8 8s are 64, so we get 64 over 3 plus, well, 6 over 2 is 3, nice easy one there for you. Take away 1 cubed is 1, 8 times 1 is 8 over 3 plus 6 over 1, again a nice easy one, plus 6. Simplify each bracket on its own, then put the whole spiel together. So 64 over 3 plus 3, well, 3 quite simply becomes 9 over 3, add it together and we get 73 over 3. Take away, well, 8 over 3 plus 6, 6 we have to write over 3, so that becomes 18. 18 plus 8 gives me 26, so it's take away 26 over 3. So 73 take away 26 gives you 47 over 3, which we can just leave as that, units squared. So there you go, we've calculated our second integral in our second area. Third question, integral from 0 to a of square root of x plus 1 all squared dx. Now, couple of differences in this one. One, it's a bracket like this, so we have to multiply that bracket out. Second thing, the upper limit is a variable like a rather than a number, so rather than a 2, a 3 or a 4, it's a. So our final answer will be in terms of a, but again, even though it's in terms of a variable, not a number, and it's not a value, we still don't include the plus c. The a is given as a limit, so we have to take that into account. First thing we need to do is multiply out the bracket so that we can make it in an integral form. So square root of x plus 1 all squared, well, what that ends up giving you is x plus 2 root x plus 1 dx. 2 root x we have to write in a different form slightly to be able to do it. We have to write it as a power, so that becomes x plus 2x to the half plus 1 dx. Now we've got it in the right form, now we can integrate. Integral of x, that becomes x squared over 2. It's then plus 2x raised the power, 3 over 2, and divide by that new power of 3 over 2. 1 simply becomes x. It's from 0 to a, there are limits. So we can simplify this a little bit. X squared over 2, well, that can stay as x squared over 2. Plus, well, 2 over 3 over 2, flip the 3 over 2 and becomes a times. That gives me 4/3 of my constant. And this x to the power of 3 over 2 simply becomes the square root of x cubed. Then plus an x there. And that's between 0 and a. This looks like a fun one, and it'll leave us with a lovely little equation at the end. But like I say, we can leave it in terms of a and any other values we get. So we do the top limit, take away the bottom limit. We get a squared over 2 plus 4/3 times the square root of a cubed plus a is the upper limit. Take away 0 squared over 2 plus 4/3 times the square root of 0 cubed plus 0. Well, that whole bracket there just disappears and becomes equals 0. So then our final answer is a squared over 2 plus 4/3 times the square root of a cubed plus a. And that's units squared. Now this sort of thing does come up, leaving it in terms of a variable, and looking at this fun one, that looks like a lovely thing to play about with. Sometimes they'll give you something like that, and what they'll do is later on maybe say, if a equals this, what is the value of the integral? Or what is the maximum value of a to give you the optimal area under the curve? This can lead into a question like that. So be aware that this sort of thing does appear and it does come up, and you still have to handle it the exact same way. Now the final question was calculate the integral from pi over 3 to pi by 2 of 1 plus 4 sin x dx. Now again, same set of steps. Just because it's a trig function doesn't mean anything changes what we do. Calculate the integral, calculate the value at the upper limit, subtract the value at the lower limit to find the difference. Now integrating this, it's in the form we can do it already. So integral of 1 just simply becomes x. Integral of sin x becomes minus cos x. So it's take away 4 cos x. And it's between the same two limits. So pi over 3 and pi over 2. Now it's giving you them in radians, so stick in radians the entire time you're working, even if it's just a value for x. So our upper limit would be pi by 2, x, take away 4 times cos of pi over 2. And then the lower limit, it would be take away pi over 3, take away 4 cos pi over 3. And this is where knowing your exact values comes into play, so make sure you know those triangles. This one here, you get pi over 2, take away, well, it's 4 times cos of pi by 2. Cos of pi by 2 is 0, so we can just drop that out. That equals 0. Then minus pi over 3, Just take away pi over 3. Minus 4 cos of pi over 3. Cos of pi over 3 is the equivalent to cos 60, which is a half. But it's minus minus, so that becomes plus 4 times a half. 4 times a half is 2. So we get pi over 2, take away pi over 3, plus 2. Now you can combine all of this into one fraction by sticking everything over a common denominator of 6 and simplifying. So you get 3 pi, take away 2 pi, plus 12 over 6. Simplify the pi's, you get pi plus 12 over 6. So we've got the final answer there, but again, units squared. Include that in your answer. Remember, it's an integral under a curve, it's an area. Areas have units. Do not forget that, because that will cost you silly marks in an exam. And that's the last thing we need to happen.